All right. Hi, everyone. So just if you don't mind to send just a quick yes, maybe on the chat box. As you know, you're mute just to keep the basically session quiet, and then I will unmute you like in about 20 minutes. So do you mind to just send a quick chat to say yes so that I know you're hearing me? Anyone? Just type yes or something so that I know you're hearing me. Guys, can someone text yes or something so that I know you're hearing me? Tanya, can you text yes if you hear me? Tanya? Alice, can you let me know if you hear me? We can't use chat. Thanks for letting me know. Can you text now? Yes. Thanks for that. That was very smart. One of you guys, he was writing, we can't hear you. Thanks, guys. Hello, guys. Hi. How are you? I hope you're doing well. Well, I'm extremely busy these days. Hello, morning, Kyle. We have this deadline for final exam questions. So I basically am really focused on that. And if you don't mind, post your questions on it. If you have emailed me already and I have not answered, really sorry about that. I'm trying to answer emails on daily basis. It's just that I get a lot of emails and it piles up, like, unfortunately, but I'm doing my best. If you have any questions, post on it. If I have to answer, they will forward it to me. Otherwise, you have to be patient. It takes 1 or 2 days or maybe more. This week, we have a deadline end of the week so that, for final exam. So, so final exam is going to be multiple choice questions. You probably get lots of instructions and details, how it's done and the dates, etc. So you'll have multiple choice questions as well as some extended questions, which means that's multiple choice questions and short answer questions. So it has like some little sections on there, one question, subsections. But I will unmute you in 20 minutes. Sorry about that, you're muted again, because we want to keep the session quiet to start with. So in today's session, there is nothing complicated going on. It's just that I'll be just highlighting a few things and I will answer a question about measure of center and measure of spread. They did ask that if I can explain a little further about measures of spread, like standard deviation and interquartile range. So let's see. I'm going to share my screen. This is it. What I want is the slides. So basically, there is not much on the slides. I'm just trying to highlight that. So we went through the simulating chance. And as you basically saw the maybe lecture videos and the lecture slides and the lab materials. They were all about simulation and probabilities. So you basically replicate those codes and just know how it looks like a correct code, how to simulate. So that's very interesting in future research. That's always something they ask you, like, have you done simulation in R? Well, this is simulation in R we did in the lecture and the lab. So this comment is repetitive. I always try to say, please make sure you read your data, etc., and use R to learn R. So the materials was about simulating chance this week, and that's what you should be basically focusing on. Apart from that, actually, before I go any further talking about the quiz, so I received this basically couple emails. There are chats. Hang on. Let me see what they say. It's just that the chat box doesn't come up sometimes, and I have no idea what to do about it. Here. They wrote on paper and held it up to their camera out of curiosity. How did that person communicate? Oh, yeah, so that was that. Thanks for sharing that. Yeah, so it's interesting that they're curious. That was quite interesting. Someone was very smart. So, okay. About quiz 6, I got a few emails. I know you were like, oh, that was a break. We didn't expect a deadline to be during the break. Can you extend it? Look, I would have loved to extend it, but then that was already too late. And many had already submitted. Plus, honestly, the deadline was not during the break. The original deadline was basically on Fridays, which was during the normal week. But we extended it to every Monday midnight because we wanted to be nice and give you as much as time possible. So this time, the last 3 days went over the break. I understand your point, but then it was too late to consider because we have a lot of students, and how are we going to do that for everyone? Many had already submitted. But look, you have 3 quizzes to basically miss out on, or basically if you get low scores, etc. So that wouldn't be counted in. But if you have a situation that you're really concerned, just feel free to email me directly. It's okay. And I will look into your case and I will help you out. Other than that, we were expecting you basically submit and then have your break and then come back, which is today. And then another quiz is going to start today. So yeah, that's what we are doing, but really sorry if you were expecting differently. And again, if you're concerned about anything, please feel free to email me. Okay, so that's that. And what else? Okay, and one more thing before I forget. So about the final exam also. So just please just stick to the materials. Or you're not gonna, we're not gonna try to give you something that we have never talked about or we never practiced. So it's not gonna be anything like surprising that you're like, oh, where this material is coming from? Where is this question coming from? So just read the materials and learn what we have done and what we have said. And that's what we want. So you have to learn what we practiced and then you'll be questioned accordingly. Okay. So highlights for quiz 7, it's going to be based off the lecture materials for this week. So it's going to be simulating chance. And again, it's coming out of the lecture slides. So if you read through and watch the videos, you'll be able to complete the quiz and answer all the questions 100%. So nothing new in there to highlight, just watch the lecture videos. And one more thing, it was like a question. Someone basically, so about quiz 7, I wanted to actually remove this, but it's still there. It's fine. So this was just part of the lecture slides. I wanted to remove this because it was already like in the materials. It was nothing new. So basically, I'm saying when playing number of games, like if you remember, part of the materials was about we played a game like 1,000 times, and then started to, after we simulated it, after we did it in lab materials, we played it 1,000 times. After we played it 1,000 times, we stopped observing like negative, basically outcome, which was we stopped losing. We were all winning. Like if we replicated 20 times, so we were looking at 20 outcome in lab materials, and they were all positive. So the point was, this is this situation is true, and actually it's consequence of central limit theorem. Well, central limit theorem basically in statistics is that when we have enough number of observations, like at least 30 observations, we can use normal distribution properties for our statistical analysis, hypothesis testing, etc. In this situation, you can say this as well, saying that if you play a certain game, like we did in our studio for, several times, like significant amount of times, then the variance of the game, it's somehow get balanced out, which means that it's not gonna risk, it's gonna be balanced out, and you start just winning. So that's interesting, and statistically we can relate that to central limit theorem. Okay, so that was like an example. I'm not sure if I have it open here, but we did that. So I didn't really want to basically repeat that, but because I just said it, how about we have a quick look? So it was like, for instance, this game we played, that I said, like, you shouldn't be worried too much about like programming, obviously simulation, but we are learning it and we are familiar how it looks like, so you can replicate. That's what we do in R. So this is basically simulation for we are playing a game with basically 10 and 100. What was the previous one? So with expected value of 10 and a standard error of 100. We had the details. And so we did play this. We looked at the outcome. So obviously mixed of positive and negatives. We are winning in some cases, we are losing. So it's risky. Risk is involved. This is the variance here. Well, I say variance. This is standard error in here, which is the square root of the variance. Usually when we want to present, I say variance because you shouldn't be confused either, like actually it's confusing. When we are representing distributions like normal distribution, the first number in the bracket is average and the second number is the variance. Like we say, a random variable X has normal distribution with mean like 10 and variance 100. Like here we are in our studio and we are basically simulating. So we are just, this is how we substitute the numbers slightly differently, the expected value, and this is the standard error given. So this is basically the risk. So risk is involved. You can win and you can lose. We don't know. So you may lose, you may win. When you play it like once, you don't really know. So we said you would play the game at least once, only if you're willing to take a risk, because you may win or you may lose. Like if each time I run this, like now you're winning, now you're losing, like we don't know. So the answer to, for instance, that question, that would you play this risky game at all? You would say you would play it if you like to, if you wouldn't mind losing money, because you may lose money. But then further down the track, so the same situation here, we said if we, for instance, play the same game 1,000 times, actually we end up not seeing any more negative numbers. So I keep simulating, I keep simulating, I keep simulating. Actually, honestly, there's no negative numbers coming out. So this is basically proving this central limit theorem that I just highlighted in revision notes, which actually is a good hint like for your quiz. There should be a point there. So make sure you understand everything about this to be able to answer your quiz question this week. So that was it. Basically, because we are doing it, playing the game instead of one time, 1,000 times, and we are having this sum out of the bracket. So we have more than one games that we are playing. We are using the sum argument here, and then this is the basically random normal function, and then number of games we are playing, expected value, which is the average. Expected value is the mean, is the expectation of the return, and 100 is the standard error here. Okay, so that was basically the point I highlighted there, maybe I let you unmute yourself and then I continue. There are a few things I wanted to highlight about a measure of center and spread today based off an email I received. So maybe before going there, I let you speak. And again, sorry that I mute you. What is the value 1 on the left of 10? Oh yes, so we play one game. Think number of times you do it, yes. Oh, I see, thanks, yes. Does the central limit theorem apply to multiplayer games or just single player? It doesn't matter, both. That's based, I see your point, So central limit theorem, you have to play more than once, obviously, at least. Like in usual cases in the statistics, to say at least 30 observations it takes to be able to use central limit theorem. So the answer to your question is you have to play a game at least 30 times. Let me unmute you. Now I'm like, I don't know how to unmute you anymore. Like it's been a long time. 1 week. Okay, maybe I stop sharing first. Okay. I usually go to, okay, unmute themselves. Yeah, now you're open to speak if you like, guys. So hello again.
Hello.
Hi. Yep. Do you any questions? Thanks for.
No questions from me at least.
Oh, sure, no problem. Yeah, so thanks for saying hi. I appreciate that. And yeah, guys, feel free to ask anything you want to say, anything you want to share. That's why we came out here to speak. Anything. Feel free to ask anything you like if I know the answer to. Any questions?
So do we need to know like the specific like name central limit theorem? Because I don't remember seeing it in the lecture.
I know. Yes, we didn't talk about this. So now I'm saying what we need to talk about it. So central limit theorem is as simple as what I'm saying in a few sentences. When we teach it in the statistic courses, we say that if you have at least 30 observations, like for instance, we have been using on a data file, and then we have some number of observations that we work on. So if you have at least 30 observations in your data file, we are able to use central limit theorem to be able to assume that we have normal distributions in the cases that we don't know the distribution of the sample. Like there are some cases that we just are not clear about distribution of the, I don't want to make you confused about that, but this is the definition of it. When we don't know the distribution of the basically sample, usually it's normal because we usually have enough data. We usually have at least 30 observations. So we're not worried about it that much, but we do teach it in basic statistic courses. And this was related to that. So long story short, if you have at least 30 observations, we do all the normal distribution properties and analysis, like hypothesis testing, etc., without being worried about what type of distributions actually our sample observations has. Yeah, central limit theorem help us to use standard normal distribution properties for our statistical analysis if we have at least 30 observations.
Okay.
It's very theoretical, like it's just a theory. It doesn't make much sense, like I can't really write it down like as a formula or anything. That's what it does, it says. Okay, anything else, guys? Like there, we're just pointing out that if you play at least 30 times, then central limit theorem, that was pointed out. But not necessarily for that to make us able to do any normal statistical analysis. Our case was different. We were just looking at the outcome, and they were coming out only positive. So we were like, okay, so it looks like variance of the game is like balanced out, and probably we have maybe a nice bell-shaped normal distribution of the outcome because we played the game so many times. So now variance is not affecting the outcome and we are not losing anymore. If it makes sense.
Yes. Could I ask a question about the final exam?
Yes.
Are we able to, are we supposed to be able to write those codes during the final exam, or
no,
it's just optional?
Yeah, so you wouldn't be asked to write a code, but you will get something like your quizzes. You will get multiple choice questions that you have to recognize the correct type of writing from a wrong type of writing. So you have to be familiar. You have to be familiar with the codes, but you shouldn't remember it exactly to write it down from scratch.
So that all the questions in the final exam should be multiple choice, or?
There are some extended questions, we say, which are, they have subsections of a short answer questions. So you may need to write something saying the keywords or calculating a number and things like that. So it will be very clear. You won't be required to write an essay or anything like that. And even if you have to write a sentence, just make sure you just say the keywords, just answer the question. The more writing is not gonna do any good. So just answer the question as brief as possible.
Thank you. Makes sense.
Welcome. Yeah, anything else? Okay. So you're still allowed to unmute yourself. I'm gonna leave it as it is unless we feel like it's getting busy. Okay, I'm gonna share my screen and I'm gonna just go through basically these little things I wanted to note based on an email. So they were asking about measure of spread, basically measure of variation. But I included measure of center as well. There are four main basically things that we better to have in mind. Is that obviously mean. So mean is as simple as you understand. You add all the observations divided by number of observations, and then we have the median, which is if you have odd number of observations, the middle one is going to be median. If you have even number of observations, you're going to add the two numbers in the middle. So look, sometimes you have 200 observations. So you have to know that two middle numbers, or even more, 2,000 observations. So you have to know the two middle numbers. So divide your number of observations by 2. Obviously, that's going to be the middle one. And then the one after. So I have seen some people add the middle one with the one before and then divide by 2. So these little things, under pressure, like when you're doing some exams and you're under time restrictions, then you make mistakes like that. So just to clarify that the middle number plus the next number divided by 2 is going to give you the median. In big samples, sometimes I've seen they get confused. And so these two, these are basically measure of center. To clarify, if you have outliers, mean is going to be very sensitive to outliers. And so we won't like to use mean as a measure if you have serious outliers. But then median is pretty robust, and it wouldn't get basically effects from outliers as much as mean would get. So median would be a better measure in when you have outliers or when your distribution is skewed. It's not like nice bell-shaped normal distribution. Okay, and about measure of variation. So we have sample variance, and we have sample standard deviation, which is the square root of the variance, and we have interquartile range. So about variance, it's a simple formula that 1 by 1, you say every single observation minus average to the power of 2, and you add them all, the sigma I from 1 to n, number of observations you have. So 1 by 1, the subscript I, 1 by 1 every single observations minus average to the power of 2, add them all, divide them by n minus 1, and that's going to be the variance. You square root it, that's going to be the standard deviation, simple. But what I want to highlight on this slide, I want to talk about variance and standard deviation, and basically how sensitive they are to outliers in compared to interquartile range. So interquartile range, maybe we didn't talk about, just so that I brought it here. That's one of the measures of variation. So it's quartile number 3 minus quartile number 1. I can just give you a quick example here. Feel free to unmute yourself whenever you feel like you have to say something. And I basically really quickly, I want to just give you an example. What do I mean by interquartile range? And make sure you won't make mistake calculating it. So one tray, just some random anything like this. Well, I just ended up having like a odd number of observations. I could do another one with even number of observations after. So if this is odd number of observations, then it's very easy. The middle one is median, obviously. So median is basically quartile number 2. That's the median. And then to find quartile number 1, you have to find the median of the upper part of basically above the median. So what do I mean by that? So including median, which is 8, 3, 1, you have to find median of this area. That's going to be your Q1. So I write Q1 here. So I have 8, 3, 1. So what is the median here? Tell me the number just to wake you up.
3.
3. Thank you.
Well, of your selection specifically.
Say it again.
Well, of that selection specifically, at least,
So,
rather than the whole column of 5 numbers.
Yes, thank you. Yeah. So we're just looking at 8, 3, 1, and then median of that is 3. And the information about quartile 1 is that, as basically I've noted here as well for you to have. So I'm saying Q1 is the median of observations to the left of the median, of the whole sample, which was 8, which means 25% of data lie below and 75% lie above basically this number. So that's what it means, like this is the median, 25% is there, and then 75% is the other side. So that's basically, these notes are just for your record, so that's what I'm talking about. And for quartile number 3, For quartile number 3, so obviously as you said that, so looking at 8, 10, 4, this time median of this part is going to be 10, and that's it. And then you can find interquartile range. So what is the number to interquartile range? Interquartile range is, I'm trying to look at the chat. When I have my screen shared, this chat box is just, here. Thank you, thanks. So we have Q3, minus Q1, that's the interquartile range. And basically the number is 10 minus 3, which is 7. So this is the basically example. One more example, I just copy paste this to make it quick. I just add one more number here, like let's say 12, just randomly, I just chose something. And so I go down here. Now I just clean this and clean this and clean this. So let's just see, what do we do? I can clean this as well. Very quick. That this time we have even numbers. So 8 plus 10 divided by 2 is going to be your median. So I just basically write it there. So
don't they need to be sorted to get the median?
Yes. Oh my God. Thank you for reminding me that. That's very important. Even this one. So was it sorted? No, it was not sorted. That's the main thing. So we have to sort this, like in R, we did that. Do you remember in the lecture? We used the sort function. So sort, and then in the bracket, that helped. So in EBUs, there must be like a sort basically section as well. Just to be quick, I just sorted myself because it's a very small number of observations. So I just come down and then put 4 there. So now it's sorted. It needs to be in ascending order. So first step is to sort it. So that's good that I made a mistake now. So now we remember. That's very important. Okay, so the median is 4. And then the median on top is 3. The median down here is 8. So the change is 8 minus 3 is 5. Thanks a lot for actually pointing that out. So if you had not, then I would have needed to come back and talk about it on it. Okay, that helped. Thank you. Okay, this one also the same. Let's organize what we have. So I just basically, if I put an 8 and 10 there, and then 12, and take 4 up there, and 3 and 1. Oops. So I sorted it. After I sorted it, the median is going to be 4 plus 8. Now it's easy. Everyone knows now. 4 plus 8 divided by basically 2. So this is my Q2 or median. And then actually a good point. So I clarified about the odd numbers. For even numbers, then so I'm thinking, what was the rule that the median on top, did I noted anything just to be consistent? So I'm not really specifying. So, okay, so that's going to be the same. So it's going to be above the basically middle point, median point, which is these two numbers are involved. So we consider both. So this side, the median of it, so it's going to be 3 plus 4 divided by 2. So I just type it here, 3 plus 4 divided by 2. that's going to be Q1. And from 4 down, so it's going to be 8 plus 10 median of this side for Q3. So 8 plus 10, 8 plus 10 divided by 2. Oops, what did I do? 8 plus 10 divided by 2 is Q3. And that's basically Q1, Q2, Q3. And
If you're speaking right now, I can't hear you.
IQR.
Now I can.
Oh, thank you. Oh my God, thanks God. I was like, oh, I think it's internet. Internet is unstable. Can you hear me now? Yes?
Yes, yeah.
Okay, thank you.
I don't know if anyone else
Yes,
had that or if it was just my end.
No. I think you were right. I saw a message saying that internet is unstable, but
Okay.
yeah, now it's gone. Okay, thank you for that.
Mm-hmm.
So Q3 minus Q1, and this is the interquarter range that we have. So the point, the last point to highlight is that we talked about outliers. We said mean is very sensitive to outliers. So when we have outliers and when our distribution is skewed, we use median. For variance, measure of variation, which are the basically standard deviation, variance, standard deviation, and interquartile range. Variance and standard deviation are very sensitive to outliers. You can experience that yourself. So you can have a sample without outliers, have a sample with outliers. Outliers are going to affect variance and standard deviation very significantly, but interquartile range is like median. It's robust and it wouldn't be affected that easy by having outliers based off the formula, obviously. So that's the basically measure of variation I would choose and I would use if there are any outliers in the model or there are like skewness in the distribution line as I'm observing, like for instance, some sort of plots. All right, so that's what I wanted to basically highlight. And this is just an example I wanted to show you, like we are getting the median of each side, and then Q2 minus Q1 is going to give you the interquartile range. This was just an example, like showing you on a histogram. And then I was just trying to have this slide to not to forget to tell you that when there are outliers, the center measure of center is going to be median, and measure of variation is going to be interquartile range. And that's basically what I'm summarizing down here. So that was from me. Now we are here. If you have any questions of any sort, feel free to unmute yourself and discuss and ask your questions. Anything, guys? And again, like about the quiz. Yep, yeah, tell me.
I don't know how on topic it is, but I know there's also a measure of 95% confidence interval, which I guess is similar. It's talking about percentiles. Is there any particular like place where you'd prefer one over another, interquartile versus 95%?
Sure, I understand. We didn't practice confidence intervals. We usually do confidence intervals. Actually, I think we will get in there. I think in this course, now I just do like, in this course, we do get in hypothesis testing, I guess. I have to look, because I go on weekly basis now, it's like I have to really check to see if we cover that topic or not. So, if we do cover the hypothesis testing, that's where we teach the confidence interval. So confidence interval here, we didn't talk about it, and we don't use it. We use it as an alternative method to testing hypothesis. So we either use rejection region approach, p-value approach, or confidence interval approach that 95% is one of the basically significance level is 5%. So the confidence interval, the confidence level is going to be 95%. That's one of the most common confidence levels that we use to get a confidence interval. That's one of the methods we use to test hypothesis. And I believe we will be teaching that in hypothesis testing. If that's the topic in this course, I have to check that.
I see. So I thought that it was just like measuring a spread of 95 percentiles centered on the median, kind of like how the interquartile range is a spread of 50%. But I guess that wasn't quite right then. It's a different thing.
I see what you're saying. Yeah, you have a point. Yeah, we don't do that there. So what you're referring to, I guess, it's that like we have 50% of observations like here. 25% is between Q1 and Q2. 25% is between basically Q2 and Q3. And then we have obviously a minimum number. And then we have a maximum number. This like, and then we call this like 5 numbers to get a box plot. This is a box plot. Box plot is made of like minimum number, maximum number, and 3 quartiles in between. So again, we think 50% of observations are here. The rest are between Q1 and minimum and Q3 and maximum. That's what we say about like this under this topic, and that's the box plot kind of lesson. Like if my note is here, my note. So if like we have a box plot, like we have this minimum, and then we have our box plot. So this is the basically minimum. I say just MI, and then this is a maximum MA, and then this is a quartile 1. This is median quartile 2, and this is quartile 3. And then we say this is 25% observations here, 25% observations there, 25% of observations there, 25% observations there. That's all I could basically connect to your point. But any question there?
Not really. I guess then, yeah, so spread and hypothesis testing are 2 different things then that I sort of conflated, I guess.
I would say probably that the confidence interval in statistics, we common use for it is in the hypothesis testing, or basically talking about 95%. It's possible that the population parameter is going to fall in between these 2, basically lower and upper levels of this confidence interval. That gives us some idea of where a population parameter is, if you're looking for a population parameter to see what's the number, for instance, for a population mean, for instance, in a question. That confidence interval will give us some idea of where this population parameter is. So we say 95% mu of this population is between 2 and 10. Then I have some idea of that 95% population mean is between 2 and 10. So that's basically the definition of confidence interval sort of information we get, and also the hypothesis testing, that's part of it.
Mm-hmm.
But any other questions? Anything else, guys? So again, like, well, we've finished what we wanted to talk about in this session. Feel free to email me. I definitely, I am answering emails. It's not that I've stopped answering emails, but if I have not answered yet, I mean, just be patient. I will do. I'm on it. So, and feel free to send questions, etc. And yeah, just feel free to email me. It's okay. And we can discuss anything, any concerns you have, like never stress too much. Just share it with us, stress me, and we help each other. And I'm joking. I'm like, yeah, so never stress. I mean, just share your stresses and concerns and we'll deal with it. We are here, we are in this together, as they say these days, right? Okay, so if you don't have any questions, I just, that's it. Any questions?
Hi, I'm a bit curious on like what does the project 2 is we need to do for, like what should we do for project 2, the individual project?
Good question. Have we started that yet? I'm a little
Not yet,
bit
just want to know. Not yet, but just wanted to know.
Okay.
Yeah,
So yeah, you scared me. I was like, oh.
No.
Okay, so I have to actually look into it as well. Like
Okay.
I go day by day as you're going. So I have to look into it, and we're gonna post like instructions and all you need to know.
Okay.
Yeah, but then after you get the instruction, so individual one should be easier because it's you, clear question, you just sit down 24/7, get it done. So group work was a little too much drama, connecting students together, but that's part of the work. We have to learn. Okay, so yeah, after instruction is out, feel free to ask. After you read the instruction, feel free to ask. But
Okay, thank you.
I don't have any updates.
Okay.
Thank you.
Thank you.
Thank you. Yeah. Anything else, guys? So apart from that, if you don't have any more questions, I stop this video here. And again, feel free to email me. Feel free to email me. And thanks for your patience if it takes at least 1 or 2 days. But I try to be quicker. Okay, then. So good luck with everything. Be safe. I'll do the same. And I'll look forward to talk to you all in the next sessions and next videos. Thank you. Thanks.
Thank you.
Thank you, guys.
Thank you.